Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over some practice problems involving salts. So the first four problems I'm going to be going over different salts and showing you how you could figure out whether that salt solution would be acidic, basic, or neutral. And then for the fifth and final problem, I'll show you how you go about finding the actual pH of a salt solution. Okay, so let's get into this. So problem number one, is KBr an acidic, basic, or neutral solution? So first thing you want to do is break KBr down into its two ions. So we got K and we got Br. So K plus Br minus. And so we want to think about, okay, where did these come from? What acid or base are these conjugates of? Right. So here, K is plus, so that could be paired up with OH minus. So you could say that that's coming from KOH. And then Br minus is a negative ion, so that would go well with H plus. And so that would be the counter ion or conjugate base of HBr. So those are the base and acid from which these come from. So you can see that KOH is a strong base. That's going to dissociate completely in water. And so that means that K isn't going to want to get back with OH at any point soon. So it's not going to be really strong enough to form or reform KOH. And so here, K is going to be neutral. And also you can see that HBr is a strong acid, and so that's going to ionize completely in water as well. Br is not going to be strong enough to react with water to bring back the HBr. So Br minus, the bromide ion, is also going to be neutral. So here we have neutral and neutral. So the solution is going to be, overall, it's going to be neutral. So that would be the answer for KBr solution. So it is a neutral solution. All right, what about number two? Is K2CO3 potassium carbonate an acidic, basic, or neutral salt? Okay, so again, first thing I want to do is break up the ions, and then second, determine what base or acid are they coming from. So we have potassium again, and we have CO3 2 minus. And just like we set up here, this comes from the base OH, KOH. And then here we have a negative ion, so that's going to go well with the H plus. So the acid that this comes from is H2CO3. Again, here we have KOH, a strong base. So therefore, it's going to dissociate completely in water. And the positive ion, the potassium ion, really isn't going to be reacting with water to form KOH back. So this is going to be neutral. Here, this is H2CO3, that is carbonic acid. It's a weak acid. So therefore, this conjugate base is a stronger base than this weak acid. So therefore, this will react with water to reform some of the H2CO3, or most likely it's going to reform the HCO3 minus ion. So this is going to be basic in solution. So that's going to be basic. It's going to act as a base to react with water, to take a hydrogen from water. And so we have neutral plus basic is going to give you a basic solution overall. So this one's going to be basic. This one was neutral plus neutral. And so we would expect this salt solution to be basic. Okay, so practice problem number 3 is NH4Br, an acidic, basic, or neutral salt. Again, first thing you want to do is break it up into its ions. So we have NH4 plus, and we have Br minus. Here, this is our positive ion. We can connect that with hydroxide ion, or we could also connect that with NH3. So where did this come from? It came from ammonia, right? So here, this came from ammonia. Ammonia reacted with water to give you NH4 plus, right? And so Br minus, again, we could add H plus to that, and we would get HBr. And so looking at each of these, ammonia is a weak base. That means that NH4 plus is a stronger acid. It's a stronger conjugate acid of this weak base. So this is going to act as an acid in solution. So we would expect this ion to be acidic. And HBr, just like we saw up here, HBr is a strong acid. So when it completely ionizes in water, Br minus is going to be left. This is not going to be strong enough to react with water to pull off the hydrogen to reform the HBr. So this is going to be neutral in solution. So this is neutral. So here we have acidic ion with a neutral ion. So the two of those together is going to be overall, it's going to give us an acidic solution. So this salt, when dissolved in water, is going to end up giving you an acidic solution. Okay, finally, let's look at this one, NH4CN. Is that going to be acidic, basic, or neutral? This one's going to be interesting. So here, again, we break it up into its two ions. So we have NH4 plus, and we have Cn minus. All right, what acid or base did these come from? So the NH4, just like we saw here, this came from ammonia, NH3, and Cn minus came from HCN, negative ion. We add H plus, and so that becomes HCN. So let's look at both of these. So NH3 is a weak base. So that means that this is a stronger weak acid. So this is going to be acidic. And this came from HCN. HCN is a weak acid. So that means Cn minus is a stronger conjugate base. It's a stronger base compared to this. So that's going to be basic in solution. So we have an acidic ion and a basic ion together. So in this case, whenever you have two ions, that one is acidic, one is basic, now you've got to compare the Ka and the Kb of these to see which one is going to be predominant, which one's going to be the stronger one. So if we look at the Ka and Kb's, now we don't know the Ka and Kb directly for the NH4 and Cn minus. So what we're going to have to do is we're going to have to calculate it using our Kw is equal to Ka times Kb. So let's look up the Kb of NH3 and the Ka of HCN. So the Kb of NH3 is 1.8 times 10 to the negative 5. So we'll write that here. So Kb is equal to 1.8 times 10 to the negative 5. That's the Kb of NH3. And the Ka of HCN, that's going to be 4.9 times 10 to the negative 10. So here I'll write it right here. So the Ka is equal to, what did I say? 4.9 times 10 to the negative 10. So 4.9 times 10 to the negative 10. Okay, so we have the Kb of this and the Ka of that, but we want the Ka of NH4 plus and the Kb of Cn minus. So we're going to have to use Kw is equal to Ka of times Kb. So the Ka of the acid multiplied by Kb of its conjugate base, or the Kb of the base multiplied by Ka of the conjugate acid. And so now we can plug these in. Our Kw, we all should know, is 1.0 times 10 to the negative 14 at 25 degrees Celsius. Unless we're told otherwise, we assume it's 25 degrees Celsius. So what do we do? So Ka, we'll try Ka first. So I'll do it in this space here. So we're going to take Kw, or maybe I'll do it over here. So Kb, so here, where is it? So we got the Kb for NH3. So that means that the Ka of NH4 plus is going to be equal to 1.0 times 10 to the negative 14 divided by 1.8 times 10 to the negative 5. So we do that calculation and we get Ka is 5.56. So that's going to be 5.56 times 10 to the negative 10. Oops, let me give myself some room here. .56 times 10 to the negative 10. Right, so that is going to be, that's the Ka of NH4 plus that I just calculated, okay? Now we need to find the Kb of Cn. We know the Ka of HCN right here, so we'll do the same calculation. I'll do it over here for lack of space. So Ka for HCN is that, so that means that the Kb is going to be equal to 1.0 times 10 to the negative 14, divided by the Ka, which is 4.9 times 10 to the negative 10. And therefore, the Kb is going to be equal to 2.04 times 10 to the negative 5. Okay, so this is the Kb for Cn minus, and this is the Ka of NH4 plus. So we look at these and say, okay, which one of these Ka, Kb values, which one of these values is largest? So here we look here, Kb 2.04 times 10 to the negative 5, right? And we have 5.56 times 10 to the negative 10. This is much smaller than this. So the Kb for Cn minus is larger. Therefore, this is going to be a basic solution when we dissolve it in water. So this is going to be basic. And that's how you figure out whether or not your salt is going to be acidic, basic, or neutral. Okay, I hope that was helpful. The next problem, my last problem, is what do you do when they give you a salt and they actually want you to calculate the pH of that salt? So stay tuned. I'll go over problem number 5 in just a second. Okay, welcome back. Now for time for practice problem number 5. So in this problem, they're asking us what is the pH of a 0.25 molar salt solution of NH4NO3. So where do we begin? Well, we first begin by deciding whether this is acidic or basic salt. What are the species that are involved, and that what reaction is going to happen, if any, right? So here we are given a 0.25 molar NH4 and O3. So let's break this apart. So we have NH4 plus and NO3 minus. So we want to figure out where these salts came from, what base, what acid. So NH4 plus, that came from ammonia, NH3. And HNO3, that's a negative ion, has we can add H plus to it. And so we get HNO3. So as we saw before, NH3 is a weak base. So that means that NH4 ammonium is a stronger weak acid. So this is going to be acidic. HNO3 is one of our strong acids. So this is going to ionize completely in water. So NO3 minus is not going to be very strong to react with water. So this is going to be neutral. Okay, so looking at our two ions here, this one's neutral, this one's acidic. So as far as pH goes, this one here, the NH4, is going to be the main character in deciding what the pH is. So we're going to ignore this one, and we're going to focus on this one. So now that we know what's going to be involved in pH, we can write the reaction of this species in water. This is going to react with water, so let's write the reaction of this in water. So if we take NH4 plus water, that's going to be in equilibrium with H3O plus NH3. Okay. So here's the reaction. And so now what we need to do is figure out the Kb or Ka of this species here. Well, we just calculated that a moment ago. So we already did that, but let's do it again. So just get more practice. So we know that the Kb of ammonia is equal to 1.8 times 10 to the negative 5. We know Kw is equal to 1.0 times 10 to the negative 14. And we know that Kw is equal to the Ka of our conjugate acid multiplied by the Kb of the base. So if we rearrange this, then we know that the Ka of our conjugate acid here, Ka, is going to be equal to Kw over the Kb of our base. So we know both of these, so it's going to be 1.0 times 10 to the negative 14 divided by 1.8 times 10 to the negative 5. And so when we calculate that, we get Ka is equal to 5.56 times 10 to the negative 10. So now that we have the Ka value for NH4 plus, which again, the Ka goes with this equation here. Now we can do an ice table. So, excuse me. Sorry about that. So we can do an ice table because we're trying to find the pH. pH is based on H plus concentration. Here we have the equation with H plus, and we're given an initial concentration of our NH4 plus in the form of a salt. So we can do an ice table to figure out what our equilibrium concentrations are. So all we're given is the initial concentration. So we'll set up our ice table, ICE. The original concentration, the initial concentration is 0.25. We'll write that, 0.25 molar. Our water, we're ignoring because that's liquid. So we ignore liquids and solids. And to start, these are 0 concentration. Okay, so we have our initial. Because this is 0, we know that according to Le Chatelier's principle, it's going to shift this way. It's going to change this way. Some of my reactant has to form product. So I'm going to have a negative X here. And since it's a 1 to 1 to 1 to 1, right? So this is, if I have a minus X here, if I'm going to subtract an X amount here, then I'm going to gain an X amount here. So, and I'm also going to gain an X amount here. So it's plus X plus X. Add the two columns together and you get, or the two rows together, and you get, for this one, 0.25 minus X. And this is just going to be 0 plus X is X. 0 plus X is X. And so there's my completed ice table. So now I can take the equilibrium expressions here in terms of X, plug them into my K expression for this equation. So the Ka, since this is an acid reacting with water, it's Ka, is equal to the concentrations of these two raised to their powers of the coefficients, which are 1. So it's going to be the concentration of H3O plus multiplied by NH3. Notice I'm not putting the 1s there. They're there, but I don't do the 1s. And that's going to be all over the concentration of your NH4 plus. So there's the expression. So now I can take these equilibrium expressions and plug them in. So this is going to be equal to X times X over 0.25 minus X. Now I can do the X is small approximation here. So if you notice, the Ka is small, extremely small compared to the original concentration. So that's probably going to be valid. You still probably want to do a 5% check. So we'll eliminate X. We'll say, okay, X is so small, it's negligible. It's not going to make a difference. So then that makes our calculation easier. So all I need to do is multiply both sides by 0.25, take the square root, and I'm going to end up with X is equal to 1.18 times 10 to the negative 5. So then to do your 5% rule, you are going to take your X value, and then if you do that, so it would be X, you take the 1.18 times 10 to the negative 5, divide that by 0.25, which is your original concentration, multiply by 100. And what do you get? You're going to get something that's less than 5%, but let's calculate that out. And we get 0.00472%. So that's much less than 5%. So we're in the clear, as far as the validity of our x is small approximation. So now we have x is equal to this x here, so we can plug these in. We're interested in only pH, so here the H plus concentration is equal to x, so here this is our H plus concentration. So H plus concentration is equal to 1.18 times 10 to the negative 5 molar. So we know that pH is equal to negative log of the H plus concentration. And we know that, so we plug that in. We take the negative log, it's going to be the negative log of 1.18 times 10 to the negative 5. And you plug that in your calculator. Let's see what we get. And we get 4.93. So pH is equal to 4.93. So that would be the pH of this salt if we had a 0.25 molar solution of this salt. So that's how you go about calculating the pH of a salt solution. Okay, so I hope this is helpful. If you found this helpful or interesting or entertaining, then please, by all means, like the video, hit that like button over there. Share this with your friends. Hit that notification bell. Subscribe to my channel. When you hit the notification bell, make sure that you hit all so you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I'd love to hear from you. Thanks for joining me and have a great day.